Okay, in this example, we have if the curve y equal ax power 3 plus bx power 2 touch the straight line y equal 8x plus 5 at the point -1 and -3, find the two values of a and b. So here we are searching for a and b, a and b. So what are the givens here? We have a not completed equation of the curve because there is a variable a and variable b. I need to find the values of them, and the value of the equation of the straight line, which is the tangent to the curve. So I have the equation of the curve and the equation of the tangent, and also the point of tangency, which is -1 and -3. And remember that this point belongs to the tangent and the curve, both of them. Okay, let's start. First, since this point is belong to the equation of the curve and the equation of the tangent, so I can substitute by x and y here and here in this equation and also in this equation. So let's start by the equation of the curve. At x at the point -1 and -3, the equation of the curve will be -3 equals a times -1 power 3 plus b times -1 power 2. By simplifying this equation, it will be a minus b equals 3 finally. So this is equation number 1. And as we learned from previous years, that if I have two unknowns, I should have two equations. So I will search for another equation to find the relation between a and b to find the value of them. The second equation, I can find it from the slope of the tangent. From this equation, as you remember, if you remember from the previous years, if the equation of the straight line in the form y equal mx plus c, m here, if the equation of the straight line is given by this form, this m here is the slope of the straight line. So since the equation of tangent equals or is y equal 8x plus 5, therefore the slope of tangent at this point, at the point -1 and -3, will be equals 8, this value. So this value is the slope of the tangent. Now to find another relation between a and b, I will use this property to find the value of a and b. Can I find the slope of the tangent at this point by another method? Yes, actually yes. We can find it using the first derivative of the function. If I find the first derivative, slope of the tangent will be equal dy by dx, as we know. So it will be 3a x power 2 plus 2bx. This is the first derivative of the given function of the curve. This is the slope of the tangent at any point, but I need the slope of the tangent at the given point, which is -1 and -3. So at x equals -1, the slope of the tangent equals 3a times -1 power 2 plus 2b times -1, which is finally equals or must equal 8, which is the slope of the tangent I already have. So the new equation between a and b will be 3a minus 2b equals 8. So here I have two equations in two unknowns. The first one is a minus b equals 3, and the second one 3a minus 2b equals 8. And I can find the solution of them algebraically by using cancellation method. So, and finally, the value of a will be the value of a will be 2, a finally will equal 2, and b equals -1. Now let's move to another example, and the final example in this lesson. And finally, the last example in this lesson. It's about find the surface area of the triangle formed from x-axis, the tangent, and the normal to the tangent up to the curve of y equal x power 2 minus xx plus 13 at the point 4 and 5 lying on it. So here we have a required triangle to find the area of it, and the triangle is formed from 3 sides. One of them is, as you see, x-axis, and the second side is the tangent, and the third is the normal. Here are the 3 sides of the triangle. So let's imagine the graph of the question. So here we have y-axis and x-axis, and also we have a curve by any figure. Let's assume that the curve is like this. Here we have this curve. For this curve we have a tangent. Let's assume that this is the tangent, and this is the normal to the tangent. So they are perpendicular to each other at this point, and the point of tangency is 4 and 5, and the needed is the area of the triangle formed from x-axis, tangent, and the normal to the tangent. Okay, let's start. First of all, to find the area of this triangle, we have to find the, as we know, area of triangle is half times base times height. So to find the area of the triangle, we need the length of the base and also the length of the height. So I will depend on the point 4 and 5. Here, if I draw a height to the triangle, for example, from this point, perpendicular height to the base, this height is of length 5, because this point is 4 and 5. So the length of this height is 5. So I already know the height, the length of the height, which is 5 units. Now I need to find the length of the base. So we have to concentrate to find the length of this base. And to find the length of this base, you have to find the point of intersection with x-axis to the normal and to the tangent. So we need to know this point and this point to know the distance between them. And to know these points, you have to find the equation of the tangent and the equation of the normal. So we will do the same thing that we already done in the previous examples. So we will first find the equation of the tangent and the equation of the normal before we start. First, to find the equation of the tangent and also the normal, we should first find the slope of the tangent by finding the first derivative. So dy by dx equals 2x minus 6, and this is the slope of the tangent at any point, but I need the slope of the tangent at the point 4 and 5. So at x equals 4, m at x equals 4 will be 2 times 4 minus 6, which is equal to 2. So the slope of the tangent is 2. So the slope of normal, as we know, it will be -1/2, the reciprocal, and then change the sign. So the slope of the normal is -1/2. Now we have to find the equation of the tangent and also the equation of the normal. To find the equation of the tangent and also the normal, we have to find to fill the form that we already know, y minus y1, which is the point 4 and 5. So I will substitute instead of x1 4 and y1 is 5. So y minus 5 equals the slope 2 times x minus 4. The equation will be y minus 5 equals 2x minus 8. The equation in the final form will be 2x minus y equals 3. And this is the equation of the tangent. And also by the same way, we will find the equation of normal. Y minus 5 equals negative half times x minus 4. And to get rid of 2, we have to multiply the equation by 2. So it will be 2y minus 10 equals negative 1 times x minus 4. So it will be negative x plus 4. By simplifying it, it will be 2y plus x equals 14. And here's the equation of the normal. These two equations are responsible to find any point on the tangent and any point on the normal. So if for example, if I need this point, I have to substitute by the value of x to find the value of y in the equation of the tangent. And also if I need this point, I have to substitute by the value of x to find the value of y in the equation of the normal. So this equation is responsible for all the points on the tangent, and also this equation is responsible for all the points on the normal. Now I need to find the point of intersection with x-axis and the point of intersection with y-axis. X-axis also by the tangent and the normal. So here, point of intersection with x-axis. To find this point, I have to put y equals 0, because when I'm lying on x-axis, the value of y will be 0. So 2x equals 3 over 2, 3. Sorry, the value of x will be 3. 2x equals 3. So x equals 3 over 2. This means that this point is 3 over 2. And to find also the x-intercept here, or the point of intersection with x-axis, we have to point y equal 0. So it will be x equals 14. So this means that the normal cut x-axis also at the point 14. Here is the value of the base. So the base length will be equal 14 minus 3 over 2, which is equal 12.5 units. So this is the length of the base, and the length of the height is 5. So the area of the triangle will be half times base times height, which is equal half times 12.5 times 5, which is equals to 5 times 12.5 equals 62.5 divided by 2. It will be 31.25 square units. And now let's take some examples to evaluate your understanding for this lesson. There are three questions to evaluate. Take 10 minutes to solve them, and then continue the video to find the solution of these questions. Thank you for listening, and goodbye.